Let p of x equal 2x cubed plus 3x squared plus 2x minus 2. Use the remainder theorem to find p of c for c equals negative 2 and c equals 1/2. Here's what the remainder theorem says. If p of x is being divided by x minus a, then the remainder equals p of a. All right, take a moment to digest that statement. If a polynomial function is being divided by a binomial x minus a, what makes this equal 0? Positive a, right? Mm-hmm. Very good. All right, so if a polynomial function is being divided by x minus some number, or for that matter x plus some number, but x minus a, then the remainder is equal to p of a. Okay, go back to this last problem here. We're divided by x plus 4, right? Mm-hmm. So if I did p of negative 4 on this, what should I get? Without working it out, what should I get? If p of x is being divided by x minus a, then the remainder equals p of a. Remainder equals p of a. So what's p of negative 4?
X.
What's the remainder?
X.
That's the divisor. What's the remainder?
179.
179.
Good job.
P of negative 4 is 179. Okay? I'm dividing by x plus 4. P of negative 4, whatever number goes in this slot here, P of that number is equal to the remainder of whatever synthetic division would get you. All right? So if I want to evaluate P of a number, this is another way of doing it rather than just substituting the number in. Notice, if I did substitute the number in, negative 4 to the 4th is 256. Negative 4 times negative 4 squared is negative 4 times 16, plus 7 times negative 4 plus 15. If we work that out, 256 minus 64 minus 28 plus 15, that makes 271, right? Mm-hmm. These two. Minus 92. $179. It's like magic. Okay, look at this one. If I did P of 3, what should it equal? 15, the remainder, right? Check it out. 9 times negative 5 is negative 45. 3 times negative 8 is negative 24. 3 to the 4th is 81. Plus 3, right? This makes negative 69. That makes positive 84. Negative 69 plus 84 equals 15. Okay, the remainder theorem is all it's saying is that the remainder is the answer to the polynomial, or the functional value. So it tells me to find P of c for c equals negative 2 and c equals 1/2. So what they want us to do is P of negative 2 and P of 1/2 using the remainder theorem. So it goes like this. I put a negative 2 right here. Okay, this is the one place that messes people up. Because the last problem, what did we do to the number here? We changed the sign, right? We were dividing by x plus 2, so we put a negative 2 there. Here we're trying to evaluate P of negative 2, we put negative 2 in. Look at this last problem. X plus 4, we put negative 4. P of negative 4 is equal to 179. So this number matches this number if we're trying to do a function of value. If we're dividing by a binomial, we're changing the sign. So make sure you make a distinction between the two tasks that we're using synthetic division to do for us. We're dividing this polynomial by x plus 2, so we're putting a negative 2 there. 2x cubed, 3x squared, 2x, negative 2. Every power of x has been accounted for, starting with the highest power of 3. Squared, first, and constant are all accounted for, so no zeros are necessary this time. If we go ahead and perform the synthetic division, job 1, move the first number down as is. Never, ever modify the first number. Whatever it is, that's what it is. Multiply, add, multiply, add, multiply, add. So negative 2 times 2 is negative 4. Add, we get negative 1. Opposite sign, so I actually subtract. Negative 2 and negative 1 make positive 2. 2 plus 2 is 4. Negative 2 and 4 make negative 8. Negative 2 and negative 8 make negative 10. So P of negative 2 is equal to negative 10. Performing synthetic division to evaluate a function. The remainder represents the answer we're looking for. Same technique for P of a half. I'm going to put 1/2 in my box over here. Again, I'm trying to evaluate P of number. The number that I'm evaluating goes in the box. No sign change necessary. The coefficients are 2x cubed. We got 3x squared. We got 2x and negative 2. Again, no powers are missing, so no zeros are necessary. The first one down is as is. Half of 2 is 1. 3 plus 1 is 4. Half of 4 is 2. 2 plus 2 is 4. Half of 4 is 2. Negative 2 plus 2 is 0. That means P of a half equals 0. All right? So if you're asked to use the remainder theorem to evaluate a function, do synthetic division. The remainder represents the answer. And that's all you have to do there, and it gives you more practice at synthetic division.